First of all, thank you everyone for being here. And I am very sorry that I could not actually attend myself. I was planning to, but with the coronavirus hitting France and down here in the Côte d'Azur, it didn't seem like a good idea to get on a plane and fly over there and infect all of my good friends. So it's been funny. At any event, first of all, I wanted to talk to you folks today about an idea that I've been working with Stephen Little and Sawyer, trying to actually finally bring modern OO into the Perl core. Because I'm not physically present this time, this presentation is going to seem a little different from some of the others. I've had to rewrite parts of it at the last minute because there won't be audience participation. But let me go ahead and get this show on the road. And, okay. Get my, and can everyone see the first slide? Excellent. Okay. First thing I want to comment about is you'll notice it says OO in the core, with core spelled C-O-R. That is not a typo. I will explain that in just a moment. But first, in case some of you don't know me, my name is Curtis Poe, better known as Ovid to the Perl community. I hack in a lot of languages, mostly Perl. I have for a long time. I sit on the board of directors of the Perl Foundation, and our company all around the world, FR, we're a French company, is sponsoring this work, doing some work with us, and we get called in when companies, when they need to have real problem solved, hard problems, and they don't want to take a chance with the regular companies who, you know, maybe they're good, maybe they're not. They need to know that they really have the expertise there. So that's what I do. If you have any questions or you want to contact us about our services, it's ovid@allaroundtheworld.fr. They're not full size? Oh, I've got the wrong ones then. Let me see what I can do to fix that. I'll try that again. Excellent. Okay. So thank you for letting me know that. So basically, part of what I've been doing recently is I've been working on a proposal to get OO in the Perl core. And the problem is core Perl OO, as many of you are familiar with, object-oriented programming in Perl, is not useful. It's kind of like the assembly language of OO programming. And I don't mean assembly language in terms of lightning fast. I mean assembly language in terms of it takes a lot longer to write, and it's painful. And the power you get out of it is great, but it's hard to get to. So Moose and Moo were kind of a game changer. There were so many different OO systems out there for Perl. Everyone was building on top of this assembly language for OO. But Moose and Moo have pretty much won. Part of what I was planning to do were I there is to start talking to you folks to find out which of the different OO systems out there, Moose, Moo, Zydeco, class standard, class simple, whatever, could you actually program in without using the docs? Since I'm not there, I can't actually do that easily, but let's say it's been my experience, most people can do that with Moose and or Moo. And I've had more and more clients tell me that their new Perl developers coming along have trouble doing that in core Perl OO. Moose Moo has one. So this gives us a way forward to understanding part of what we're trying to do. But it's not in the core. And the question is, what should be in the core? So in our particular case, core, C-O-R, is a proposal to add modern OO to the Perl core, make OO really easy. And in fact, the way we're envisioning this is it's going to be much more powerful than OO available in many other languages, with some caveats to that. But what we're trying to do is we're trying to strive for an MVP. What is the smallest thing we can get into the Perl core, which would actually be awesome to program in, but it's small enough that P5P says, yeah, we're willing to take a risk with that. But it still needs to feel like Perl. So Sawyer is fairly receptive to the idea. There's been a lot of discussion there. Stephen Little, he's hacking on a prototype. The idea being the same thing with Audrey Tang and Pugs that fleshed out so many problems we had with Perl 6, now named as Raku. And I had a prototype, but my prototype was awful because I was too much in the Moose mindset. And that was unfortunate. I needed to get out of that, and now I'm out of that. And you'll see what I'm talking about later. But we're also paying attention to community input. but we're not making it a democracy because, well, that's just the way we are. So I want to make it clear that all the core syntax that I'm showing is highly speculative. There are zero guarantees, and data types are for entertainment purposes only. There's a possibility that data type checking will not be in the first version of core. We're unsure. And part of the reason is I don't know which of these we go with. Has int 2 is actually current Perl syntax, more or less, if it was my instead of has. The second syntax actually fits core a lot better and it's probably easier to extend, but I'm going to punt on that for right now because that is the least of our problems. But if you're wondering about the name core, this is actually short for Karina. Those of you who are unfamiliar with the name, the poet Ovid, 2,000 years ago, wrote lots of beautiful poems of a woman named Karina. And so I just chose the name core because, well, I'm Ovid, and it's also a nice sounding name. So what's wrong with moose? Why don't we put moo or moose into the core and just call it good? Because we don't want good enough. We want better. And moose has some really, really bad affordances there. It actually encourages some bad practices. As Stephen Little created moose, he admits this. And you're going to see some use cases coming up which are important, but they're very clumsy to do in moose. And I've also been looking at Raku, trying to steal some ideas from there. So Moose 0.01, this was released back in 2006 by Stephen. You can see it looks pretty much like the Moose we have today, except you had to import strict and warnings. You can see, is it int? Int was a subcall, but mostly it's what we expect in Moose. So this is a point class that we had there. I should have put in the strict and warnings example, but I didn't. This has some problems, which we'll touch on more later, but basically, how many of you have heard of Moxie? Just a show of hands. Okay, I've seen a few hands. This is Moxie. This is Stephen Little's attempt to kill his baby. So he created Moose. There's some problems. Here he's creating Moxie. What we have is has X, has Y. That is a slot declaration. That is declaring your instance data. And that is all that it does, aside from, in this case, assigning default values. And this, the sub X, sub Y, that's where you declare your accessors for this. And in this case, they're both read-only. And then we have this horrible abomination. Oh, pardon? There is a problem? That's okay, I can go again? Okay. Okay, good. So in Moxie, you declare your slots. And here we're declaring the methods to read that slot data. It explicitly decouples the declaration of the data and the access to the data, which is important. Unfortunately, it means you have abominations like this, where we have this internal hash slice that we're assigning to in order to be able to mess around with that, because those are read-only attributes. That's kind of ugly. So this is core. As you can see, core is much simpler, much cleaner. We don't have square brackets around the X and Y. We have parentheses because we want has to be a proper declarator like my and our. And we have a reader for it. We don't have a writer. However, every class or subclass is allowed to mutate its own data. This is a compromise we made in order to make things easier. So the clear method, inside you can set X and Y. Outside of this class, you would not be allowed to. And you can see we have the default. So we put these side by side. You can see core is a lot simpler than Moxie in many ways. And part of what Moxie is trying to solve is this problem with Moose. The has function handles data, attributes, types, coercion, delegation, clears, predicates, blah, 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 blah. It handles a lot. It handles too much. Trying to pack all that functionality into a simple syntax is problematic. And that's part of the reason why we can't put moose in the core. So why don't we put moo in the core? It's simple, it's lightweight, yeah, it has those problems. Well, that's actually not backwards compatible because moo has a fake meta class, which if you call it, it expands it into moose. If you put moo in the core, you have to put moose in the core, or you break backwards compatibility with moo. And moo also has some of the same issues here. But moving along, we have a trial grammar for core. I wrote this up. It is not guaranteed to be perfect. It's simply so that we can have a very clear understanding of where we're starting from when we discuss how core is actually going to function. And also, one of the many reasons we need core is I was trying to debug a performance problem with some client code the other day. It was code written in Moose. And my slowest methods were all Moose and Moose-related things, well, aside from the try-tiny. So this is a huge frustration we see all the time. But let's stop that now. Let's talk about OO. A lot of people say that object-oriented code is bad. It's not what we actually want. You're doing it terrible. Just stick with procedural or functional or anything but OO code. And let's look at some bad procedural code. Some of you remember stuff like this from the early days of the web, and virtually every single line of this was broken. It worked, but it was broken for all sorts of use cases that I won't get into now. And what happens if you see this? People say, let me help you. I'm going to help you. And they say, look, I'm going to help make your code better. Here's some best practices you might want to think about. And we've got a lot of best practices. We're actually really comfortable with procedural code and how to make it better. But what about bad OO code? Well, I'm not even going to touch on it, but there's a number of problems with this particular object class, which has a name that you can get and set. And what are best practices for OO code? It's all over the place. Python says we shouldn't bother to validate our object attributes. If you want to assign a date time object to your customer name, fine, that's your problem. Perl has that horrible bless. Dr. Alan Kay says everybody does objects wrong. JavaScript objects are just, basically data structures. It's really hard for people to agree on what good object-oriented programming is if we can't even agree on what objects are. So we're talking about best practices, though. In our case, we're focused more on maintainability, less so for correctness. Correctness is a slightly different problem, and adding types to it doesn't quite solve that problem. It doesn't even solve that problem. In the case of core, we're going to punt on the whole what is an object thing, because in this particular case, Moose and Moo have mostly won in the Perl world. So we're going to go with that. We're going to stick with that, and we're going to push that along. So we're skipping the entire debate about what is an object, even though our work is rather opinionated in many respects. If you want to learn more about best practices for object-oriented programming, I highly encourage that you consider SOLID. SOLID is just an acronym for single responsibility, open, close, a few other things. But this is not a talk about SOLID, because I could spend an entire hour talking about SOLID. I can spend an entire hour talking about each of those points in SOLID. So we're going to skip that too. We're just going to dive straight into core. It's very opinionated. It's very Perl, and it tries very hard to be practical and not just theoretically pure. So we're going to use a simple object as an example of some of the issues that we're trying to deal with. So in this case, we have a customer object. They've got a name, they've got a birth date, and they have an optional title, such as Dr., Ms., whatever. And methods, we can get their full name, which is their name prepended with the title, and whether or not they're old enough to vote, drive, et cetera, et cetera. The main thing for this particular object is just checking, are they old enough to do various things? So here's how it might look in Moose. You can see in the red, we have the title, name, and the birth date, some attributes we've declared. Then we have the various methods below, the full name, old enough to do stuff. And notice we have all these attributes declared as immutable, read-only, and that's great. Why is that great? Well, take a look at this. In this code, we've created our new customer, and if Ovid is old enough to vote, we do some stuff, and then someone tries to set the birth date to yesterday, and the code throws an exception because it's read-only. Why? Because when we entered that state, the object said, yes, I am in an acceptable state for you to do this thing, and then internally, we can change the state of the object so that the assumptions that we made are no longer valid. So that's one of the many reasons why immutability is a fantastic thing for objects. But that birth date's actually a reference to a date time object. So you can still set the year to last year, and all of a sudden you're in an invalid state, and you don't know if this is true. You don't know if you're in a good state. You don't know what's going to happen, and that's unfortunate. And this is actually a real world problem. So Ricardo posted a great blog entry explaining one of the issues he had with mutable state. That led to datetime moonpig. There's now a datetime x immutable there. I've had to deal with immutability with quite a number of clients, and it's certainly a problem. So here's something you might want to consider. So DBX class, how many of you use it? Show of hands. Okay, here's how you make DBX class inflate to an immutable date time. So you declare your DBX class component, you inherit from DBX class inflate column date time, and then you override the post inflate date time method. You call your parent method, and the date time object you get back, you just cast that as an immutable date time. And now you include that component inside the DBX class, and all of your dates and date times will inflate to immutable objects. So it's still not perfect, but that's because DBX class tends to use objects as smart structs rather than objects in the sense that we're presenting here. But it can help quite a bit. By the way, thank you very much to Peter Mottram for pointing that out to me. So core, guiding principle number 1, immutability should be the default. So that's one of the things we're trying to focus on. So for our object, we've got a new business rule. Customers must always be addressed by title and name if the title exists, never by just their name. So the very, very serious business rule. So we have this full name method right there, as you can see in our object. And in displaying the full name, you can see here later, we have customer full name. Great. But someone's going to call the customer name method. Because remember, that attribute was listed as read only, and it's public. So someone is going to call it by customer name, and they're going to violate your business rule. It's going to happen. You can't stop that. So what do? We want the name attribute to be private, but we don't want to pass underscore name to new because that just looks ugly and wrong. And by the way, if you've already released the code, name is now part of the contract. Part of what we're trying to do with core is to reduce the size of your objects, the size of the interface of your objects, so it makes it easier to make these sorts of changes later. So if we don't want to pass underscore name to new, how can we handle this? Well, here we have underscore attribute, we have has underscore name, and then we have an init arg called name. So that's the name of the argument you pass to the constructor in order to set the underscore name attribute. And later on, when someone calls customer name, we get a method not found, which is the behavior we want. Except someone's going to call customer underscore name. You know it. You've seen this in production code. It's frustrating. You really don't want to do that. So how can we fix that? Make sure that they really, really, really can't touch that. You really have a private bit of data there. You can say is bear. Has name is bear. And it's required, so you've got to pass it to the constructor, but now there's no method for it. But how do you get that data? Well, inside of your code, you say self meta get attribute name, get value, self. Nobody does that. I mean, that's how you get this private data with no attributes in Moose. No one bothers. They just go ahead and they make that public because it's easier. So init, arg, and bear and Moose, they're clever solutions, but they're very clumsy solutions because has conflates state with public attributes. So that's, again, part of what we're trying to fix. By the way, a little pro tip when you're designing objects, don't provide any data methods. No access to any of your data. Up until the point where someone actually needs that data. Then go ahead and provide a read-only attribute for it. It makes your classes much easier to work with, especially when you're doing heavy refactoring. But it's hard to do in Moose. It's easy to do in Core. So private data should be easy, and we do not want to encourage promiscuous data. Don't throw this data all over the place because people will rely on it, and it's harder for you to change later. So here's what that looks like in Core. Again, the data type declarations are suggestions right now. We're not sure that's the way it works. Name is a string. we're still working on exactly how the constructor attributes are going to work, but in this particular case, for this version of core that we had, name would be required to pass the constructor, and then your method name, you don't even have a full name method. You just have method name, return title, title name, name. It's much easier to write, and no one can read the $name attribute outside of the object that you have. So we have truly private data, but we make it very easy for you to expose it if you need to. So attributes, let's talk about those for a moment. Sometimes methods are very expensive. And I've had cases where I've been running some code and I've got an expensive method that's been at the bottom of a tight loop and it keeps getting recalculated, but it calculates the same value every time. And I'm like, oops, I didn't want to do that. So I want to convert that to an attribute, because an attribute, you calculate the value and it's done once and only once. So here's a box class. We've got a height, width, and depth, and we're going to pretend that volume is an expensive method to call. It's not, but let's say it is. So how would you properly convert that to an attribute in Moose? Given that you don't want people to be able to set the volume, volume must be calculated, because if they pass in a height, width, and depth of 2 each, the volume would be 8 cubic units. You don't want to be able to set it to 23. So here's how you actually do that. You declare it as read-only. You say it's a num. A init arg you set to undef to make sure no one can pass in the volume. It has to be lazy because you need to make sure. Okay. Okay. So we declared it as lazy because we need to have the height, width, and depth set before we calculate volume. And then we have a builder method down here called build volume, which calls build volume. And now volume will be calculated once and only once, which works great for immutable objects because you know you don't need to calculate it more than once. And it's very straightforward. No, nobody does that. They're just going to make volume a method because, oh my goodness, that's so much easier to do. How do you replicate this behavior in core? Has $volume, we've got a reader, no constructor, we're probably going to change that to private. And we say it has a builder, and then we build volume method. And it just does everything you just saw, but it makes it very, very easy to declare this attribute that you have once and only once. Here's a side-by-side comparison. I know which of those I would rather program in. So core is simple, straightforward. But let's look at attributes a little bit more. In this case, no constructor means we shouldn't pass it in the constructor. We could also pass in optional, which means it's optional for the constructor. And having neither of those means that it's required in construction, but we might put in a required attribute. But this is actually getting kind of ugly. And passing in both no constructor and optional, that would be an error. Why doesn't Java have this problem? Why don't a lot of other languages have issues with object construction and figuring out what args get passed? So we're gonna take a look at object construction real quick so you can see exactly what we're missing. So on our constructors here, here's a box class. We set the height, width, and depth, and we calculate the box volume. And I'm just using a method instead of an attribute because declaring that as an attribute is a pain, as you saw. But what a cube is a special type of box, the same length on each side. So I just want to pass in the dimension 7 and say the volume, but that's a single argument, not this list of pairs. So I've got to try and remember the syntax for build args. If 1 equals args, my num equals args 0, and then I call my constructor properly with the correct args, and it works great, except you're also allowed to pass in a hash ref to Moose instead of just a list of key value pairs. Then we get a data type failure. So then we have to remember to put in if 1 equals at args and not ref. Every time you have to do stuff like this, it's more stuff to remember, it's more potential bugs which are lurking. And in fact, when I write build args methods, I say, forget it, I'm tired of that. And I put this magic voodoo line noise at the top which mostly works. And it's an embarrassment. What about Java? So here's the same box class in Java, double width, height, depth. So box, we have our first constructor, which takes 3 arguments. By the way, Java does not do named arguments. It's just not a thing for them. There's some discussion about doing that, but it's not caught on. We have a second constructor called double len, which just takes a single argument. And by having 2 constructors, you can see right here, the box 3 to 3.5, we print out our volume of 21. Then our cube, new box 7, print out the volume is 343. It has method overloading. It knows which constructor to call by inspecting the arguments. So Java, notoriously verbose, is simpler and easier to read than the Perl code. I don't want to have to deal with that. And in fact, a lot of times I don't. I just declare a different constructor because I get to skip all that and it makes life easier. Maybe that's not the best way to do it, but that is so much simpler. And, I forgot about this. I wasn't planning on putting this here because I was planning on actually physically being present, but here. Can you guys hear that music? No music? Okay, well, that's unfortunate. Anyway, this is a prototype. No one's actually seen this video before outside of a few select people. This is part of the cowstation.space free to play narrative MMORPG we're creating. For those of you who don't have a lot of experience with Perl, the entire back end of this is built in Perl. And I wish I had had core when we built this, because this would have made our life so much easier. I'll go ahead and stop that. So when I was writing the code to allow you to travel different rooms or different space stations or different star systems, it looked kind of like this: sub, travel to, stealth, destination. If destination is room, if destination is station. If it's not a room or a station, it must be a star. Yeah, that assumes that I definitely passed the correct type of object in there, and I don't know that I have. I have to be very explicit about this, and this code's getting ugly with this if, else, if chain, and then having to remember to throw an exception if I didn't get the right type of object in there. If I had method overloading, I would have 3 separate methods, 1 for each type of destination I could travel to, and it's much cleaner, and I wouldn't have to write the else condition for throwing an exception if it's not there, because that would be built into the language. The language would be handling this for me, not me remembering to have to write all the scaffolding code to work around that. But constructor and method overloading, that does require signatures with types. Dave Mitchell's doing beautiful, beautiful work with this, but we're not going to get method overloading. We need a protocol for signatures. So this brings us to one of the problems I'm having with core right now is we need to make constructor args easy, but how? Without method overloading, there are some issues there, but I'm going to skip that right now. So old school OO, this is how we used to write OO in Perl. This is a lot of cutting and pasting. By the way, I've got about 5 minutes left. Is that correct? How much time do I have left? Pardon? 10 minutes? Okay, good. So this is, you can see Moose compared to the core Perl. Obviously, it's a lot smaller, a lot simpler. Here's core compared to Moose. Very declarative, very easy. And part of why we want to have core in core is because everybody and their dog is arguing about how objects should be done. And it's an embarrassment. So we're just trying to make this go away. So most of those object systems out there, many of them, they're just for public methods for your data. And there's so many of them, we knew we had to make getting those public methods easy. Moose almost requires public methods. It's very hard to not have them. And everybody wants them. So we need to agree that attributes for data should be easy. So let's get a more advanced example. This is a class which is not immutable, but is going to have a nice interface here. So here's an LRU cache written in core Perl. Basically, it's a least recently used cache. So it'll cache a few items, and the more often the object's returned, the more likely it is to be in the cache. Here's that in Moose. It's a little bit smaller. And there's core. Obviously, much easier, much simpler. Now this created slot that we have there, notice it says immediate. That means that it is not lazy, even though it's an internal thing. In case you want to find out exactly when an object was created in this particular one, this is an example of how we're making the system flexible enough to handle particular needs that you have. You can see the cache itself. Obviously, a cache has to be mutable. To make it immutable means you would create a new cache with new items in it every time, which would kill the performance benefit that you're expecting to get out of a cache. But there's no way you can actually get to this cache from outside of this class. And note, because it looks like a variable, the code is very simple, very easy to follow in this case. Here we do have some public data. It's read-only. That's the max size of the cache. You might pass that in as a value for the maximum size we would allow in there. And this actually looks very similar to Raku. I tried writing this up in Raku. This back in the days when it was called Perl 6. It didn't actually work because it turned out the ordered to hash class was sorted class, not ordered. So that was unfortunate. But you can see very similar. And just looking at Moose back here, you can see how much cleaner and easier it is to write in core. So has, like my, declares variable. It declares an instance data. That is all that it does. It does nothing else. It is all of these attributes that we are working on, which controls everything else. So we've managed to decouple all of these responsibilities. And there's a variety of attributes. We haven't settled on all of them, but it gives you virtually everything you have in Moose and Moo right now, just easier to do. There are some illegal combinations of attributes. I'm doing my best to make this list as small as possible. And actually, some of these illegal combinations are no longer illegal. That's part of what I've been trying to do, is to make it such that you can write core and create your attributes and make it very hard for you to create an attribute that's illegal. It should just be easy to write. So this is a lot of what I've been doing. So these last two core guiding principles don't really fit anything that I said before, but I wanted to put those in there. Core needs to support types. We don't know if it'll be in the first version, and it should work seamlessly with native OO. So if you want to inherit from an existing class, but write your new code in core, that's fine. And types, I won't get into them right now. We're running low on time. To work on this, Sawyer's been discussing some ideas. I won't really get into that because I don't want to step into his territory, but there's been some very positive things coming out of that. Stephen is, again, he's looking at writing a prototype, and Paul Evans actually wrote Object Pad to give us a chance of understanding how lexical variables can work in this case. And we actually have a chance for a new beginning here. So what happens there? Right in the center of cache LRU, inside of this postfix block. Some people don't want the postfix block, but it turns out this introduces a new scope, which is much easier to work with than a file-based scope. And because this is a currently illegal syntax, we can do anything we want to in there. For example, we could make all of these features or more the default. No more stricter warnings. You'll automatically get signatures. Indirect object calls, yeah, that's automatically fatal. We could possibly remove those from the lexicon. Who knows? Maybe we can add native exceptions. Maybe we can add try catch. Look at all the stuff and deprecated, and it's not allowed inside of a class block. This gives us the ability to move forward, but we don't have to stop there. What if we have module string utils? This would be like a class, except it's procedural code instead of OO code, getting us a nice, clean, modern language. So class and module keywords would be introduced, and because the language changes are lexically scoped in a way that would be illegal in older Perls, we don't have backwards compatibility problems anymore. But it is hard work. We do have limited resources. So I do want to set some expectations there. If we can get core in the core, it's going to end the embarrassing, how do we do OO, go out to the CPAN and go through a couple of hundred modules to figure out which one you actually want to use. It's going to be much faster than Moose or Moo, assuming that it's all written in C underneath. Standard O is going to be easier to learn, and it's going to be better than many other languages, particularly since it's going to be supporting roles. And eventually, when we get the types in there and our richer type systems, I think that will be lovely. But it's not going to be soon, because we have to get this right. We don't want to do stuff like we did with pseudo hashes, where that got in the core and it turned out to be an absolute mess, or smart match, stuff like that. So there's a lot of things we've got to do. Build args, or something similar is going to remain, because we're not going to get the method overloading. So we're going to have to figure out some other way of setting up construction. There's a lot of things that we're trying to get to, but right now we're trying to figure out the MVP and try to make sure it's exactly what you actually need. And I think I finished just on time. Wanted to say thank you. Do we have time for questions? Yes, I actually heard that little bit. I even saw them applauding. Hands were flailing back and forth. The question is, will it be ready by Christmas? And the answer, of course, is yes. Do we have other questions? Why don't go, we're going to reinvent the language inside of those blocks. Why don't we just what? You mean inside of Perl 5? No, because I work with lots of clients. We can't break backwards compatibility. I work with lots of clients who have stuck with Perl for so long because it doesn't break, and they can upgrade it, which means we need to reduce the scope of changes in such a way that they can still push forward without breaking their existing code. Do we have any other questions? Okay. Now I understand what you're saying. Making the class and module blocks be Raku instead of Perl. That's a nice idea, except there are some serious issues with that. Not the least of which is we would get lynched if we did that. So we would have to have a brand new lexer. We might do, pardon? We'd have to have a brand new lexer. We'd have to, are we going to keep the invariant sigils or not? That would be the first thing. We've also discovered with backporting features like smart match into Perl 5 that translating from Perl 6 to Perl 5 semantics doesn't always work. Lists don't, arrays and hashes do not flatten out in Perl 6. What happens when you're calling back and forth with an array or a hash? What's the semantics on that? We need these blocks to actually be Perl 5, which in some cases is suboptimal, but by keeping them Perl 5, we don't have surprises about different semantics. And that is important. Plus, it is easier to do by having something which we can actually build on and have working. And Raku, also, its performance is not yet there. Not to mention the fact a lot of the things Raku does with threads under the hood, the parallel programming, you're not going to backport that into Perl 5 either. Any other questions? Excellent question. Are the objects still blessed hashes under the hoods? There's a definite possibility of a firm maybe. The idea is we would like to be able to take that away so that we have the freedom to implement objects in possibly completely internal. So you would never actually see them, but we would possibly provide handy dump methods or something like that so you can still see the data. The first pass is likely to be blessed hashes, but I'm not making any promises. we want to make sure that we have that sufficiently encapsulated so that we can feel free to change that. And I think with the lexical declaration of the variables, it might actually be easier to not make them a blessed hash at this point. I do not know. Are there other questions? Regarding some of Matt's comments about this, Matt's made some great contributions to the discussion of core, and I've definitely had some conversations with him, pitching in from time to time. But we're keeping this small right now with just Sawyer, Stephen, and myself focusing on the core ideas and then reaching out to other people. We'll probably bring some more people in at some point when we actually have enough done so that other people's contributions will actually make sense there. The question is, what happens when you mix this with Moose inside the program? In theory, that should be just fine because you can inherit. The intention is that you're allowed to inherit from any non-core class. Though in practice, that's going to be hard to guarantee. For example, one of the things about core is that it should default to C3 method resolution. When you're inheriting from something which is not expecting C3 method resolution, what happens if you have some sort of diamond inheritance? Like if you look at the inheritance hierarchy for DBIX class, you just want that to go away. You never want to look at that again. Catalyst does similar tricks. So you want to skip a lot of those things. But that's our hope. With single inheritance all the way down, it'll probably be easier. Though we will support multiple inheritance. I don't want to have you think that we don't. Do we have time for more questions? I'm sorry, what is the question? Okay, the question is, what happens if a vanilla class tries to inherit from a core class? And I don't have a good answer for you other than it should work. However, one thing to be aware of is core is going to be inheriting from a different universal class. And there's going to be some different behaviors available down at that level. Not all of those have been spec'd out because that's the least of our worries right now. So that's something a vanilla class inheriting from core might want to be aware of, the fact that the root class of all of that is probably not going to be universal. Therefore, folks should be aware of that. But once core gets in there, I can't imagine why a regular class would want to inherit from core. Why not just write the new code in core? Any other questions? Okay, the question is, do we have any idea of how we're going to implement the type system? Will it be compatible with TypeTiny or other systems? There's two possible syntaxes for this. One is, say, has string $foo. The other one is has $foo : is a string. The second one, going with the attribute declarations, is probably the way we're going to go, and that's my guess, and that would allow you to possibly import your own types. So we would have some basic types that we would be providing, things which are a little bit more universal, and going a little bit beyond string, char, int, etc. But 0 or positive int, positive num, stuff like that. Tossing a lot of things out there that people want, but also allowing people to declare a UUID type. And you can say this attribute, it must be a UUID. We probably don't want to put that inside of the core of core, but that is a sort of obvious extension that people would want. So in other words, yes, we would like to do that, but that might be version 2. Anything else? Okay, let me just finish up with this. I am, again, very gutted that I was not able to be there in Germany with you. I was really looking forward to catching up with a lot of you folks and also seeing the lovely town there. I want to thank everyone who's been putting together this conference, and I really appreciate how accommodating they've been, given that I had to cancel my trip at the last moment due to this problem that we're having down here. So I'm very sorry about that, but I'm very happy to see all your faces again. So thank you. As usual, you folks can contact me, Facebook, Twitter, however you want. Ask for some of the links of some of the stuff that I've discussed before, and I will try and get a version of this talk up on SlideShare at some point so you can take a look at it, though already some of the things we do have in the slides is already out of date with some of the new attribute work that I've been doing. So thank you.